طيب I may to at a certain point أبلش أخذ حضور غياب وأنزل على السيستم يعني. طيب. ما بعرف إذا أنتم انتبهتوا، بس اللي أنا عم بعمله by the way إنه عم بقسم التيمز meetings into channels بحيث إنه كل محاضرة تكون let's say a different channel. In case for instance if you need to refer to any of the recordings أو أي من النوتس اللي إحنا عم نحكي فيها بيكون already مقسمة هاي الchannels، فبتكون كثير أسهل لكم to access it. طيب هلا إحنا المحاضرة الماضية if you recall حكينا عن what? Do you remember what we talked about last lecture?
دكتورة وصلنا عند ال topoisomerase 1 and 2 and what they are doing.
Yes, we did talk about, let's say, topoisomerase as being a target for a drug of anti-cancers اللي احنا sorry. بنسميهم ايش؟ What is the first drug class that we have talked about last lecture? Intercalating agents. طب based على name, what do those intercalating agents do? What do they interact with? DNA, all right? What is specific, or what are the pharmacophoric features specific for intercalating agents? Yani how can you recognize an intercalating agent if you look at its structure?
The planar system.
Yes, is that they have a planar, let's say ring system. يا إما بتكون a fused ring or attached ring which are planar. And what they do is that they insert themselves in between base pairs with DNA, and that's why they are called intercalating, because they can intercalate themselves between base pairs with DNA. And that's not the only interaction that happen. يعني مش فقط بيرتبطوا في DNA and that's it. There are the consequences of their binding to the DNA is that they can also, or they do have the ability also, not only to complex with DNA, but برضو كمان to complex with very important proteins for DNA replication with DNA transcription, such as, do you remember the enzymes that we considered high intercalating agents as poisoned for, or poisons for? Topoisomerase 2 اللي حكينا عنه, which is, let's say, a target for doxorubicin, and the DNA-dependent RNA polymerase. Okay. هلا بهالسلايد وزي ما حكيت لكم يعني أنا السلايدز أو الفيجرز الزيادة اللي عم بحكي فيها في المحاضرة واللي مش موجودة عندكم بالسلايدز واللي يوجوالي بحط هيك around it a blue frame. الفكرة منها بس عشان بدي أنا أشرح كلمة term sentence معينة موجودة عندكم بالسلايدز، بس كل هاي الديتيلز اللي موجودة in such figures مش مطلوبة منكم. That is why I do not include it بالnotes. هلا this figure shows you the difference between what we call as an enzyme inhibitor and let's say an enzyme poison أو اللي إحنا بنسميهم suicide inhibitors. What is the variation between them? هلا inhibitor, as you all know, is a compound or a drug that binds to its target, such as an enzyme, prevents it from binding to its substrate. يعني topoisomerase 2, DNA dependent RNA polymerase, those enzymes are considered our substrates. Our substrate for them is what? What is the substrate of those enzymes? يعني مع ايش بيرتبطوا بيعملوا, let's say, their catalytic action, which is DNA synthesis or RNA synthesis. Oh, sorry, يعني topoisomerase does not do DNA synthesis, وإنما let's say relief of supercoiling or catenation. What is the substrate for those two enzymes? DNA. So they bind to DNA, whether topoisomerase or DNA or RNA polymerase, those two enzymes, their substrate is DNA, and they act via binding to DNA. All right, so DNA is their substrate. Now, an inhibitor of those enzymes is a compound that binds all right, it binds to the target enzyme and prevents it from binding to its target أو its substrate which is the DNA. Okay? يعني بيرتبط في الإنزيم قبل ما الإنزيم يرتبط بالسبستريت. As for a poison أو إحنا إمتى بنعتبر a compound being a suicide inhibitor أو a poison, it's when the compound has the ability to bind to the enzyme after it binds to its target, to its substrate. يعني بيرتبط بالسبستريت والإنزيم, stabilizing that complex, which will eventually lead to, let's say, DNA breakage, eventually provoking the programmed cell death or apoptosis, which leads eventually to the killing of cancerous cells. فهمنا الديفرنس؟ اوكي؟ يعني الانهبيتور بيرتبط بالانزيم قبل ما يرتبط بالسبستريت، بيمنعه يرتبط بالسبستريت، لكن البويزن it binds to its target او to the enzyme حتى بعد ما يرتبط بالسبستريت اللي هو ال DNA as you can see. Okay, forming a very stable complex and eventually the net effect for those سواء كان الانهبيتور أو حتى كمان الsuicide inhibitor أو الpoison is the same. Eventually it will lead to cell death. Alright, هلا حكينا if you recall عن الدوكسوروبيسين إنه main mechanism of action for it is that it binds to that complex of topoisomerase with DNA, stabilizing the topoisomerase with DNA complex after already the DNA is broken, فبالتالي بيمنع يصير في ligation, and this is what eventually leads to DNA breakage. Okay. هلا another known mechanism in literature for doxorubicin C, for doxorubicin, via which it eventually leads to cell death of cancerous cells اللي هي it increases reactive oxygen species in cancerous cells. Now how it does that يعني مش مطلوب منكم تعرفوا exactly الميكانيزم، يعني هاي الفيجر الزيادة اللي أنا حطيته just to show you that doxorubicin C sorry إنه دائما بحكي C doxorubicin it binds or it chelates iron، والiron لما يكون oxidation state له 3+. Do you know what is it called? Ferric iron. Okay. هلا when it chelates with ferric iron, what happens is that eventually بصير في عندي let's say reduction of that ring in here. هلا لما يكون عندي a 6-membered ring with 2 carbonyls. Do you know what we call this ring? هاي بنسميها a quinone ring. Now the 2 oxygens in here in the structure of doxorubicin can chelate iron, ferric iron. Iron بيصير له reduction. All right. Now الكينون بيتحول عندي into a semiquinone where you have now one of the oxygens as a radical. وكلنا بنعرف إنه generating radicals in cells will lead eventually to interactions مع الwater بحيث إنه بيتكون معي free radicals اللي هم ال OH radical أو ال OOH radical واللي collectively إحنا بنسميها reactive oxygen species. هلا those reactive oxygen species, if their concentration is very high in cells, this will eventually lead to cell death. So that's another mechanism via which doxorubicin acts. فبالتالي بتوقع إنه أنا لو شلت هاي الكينون part من الدوكسوروبيسين الactivity بتوقع إنها قل بشكل كبير. Yes, because this is a very important part in the mechanism of action of doxorubicin. All right. طبعا الcancerous cells are more affected because خلينا نحكي their mechanism أو يعني one of the ways via which we can let's say affect the cancerous cells by increasing the concentration of reactive oxygen species in those cells. طبعا بصير في عندي كمان an increase reactive oxygen species in normal cells. لكن generally mechanisms via which high reactive oxygen species بصير لها sequestering بالcells somehow effective, except for the heart. هلا one of the reasons why doxorubicin is associated with cardiotoxicity إنه لما يتكون عندي reactive oxygen species in cardiac cells الميكانيزم via which high reactive oxygen species are quenched بالهارت مش as effective as other cells. فالهارت بتأثر بشكل كتير أكبر مقارنة بالother tissues. Alright? This is another intercalating agent. Mitoxantron. Okay? Look at the structure of doxorubicin and compare it with mitoxantron. هل في تشابه بينهم؟ Yeah. Almost نفس let's say planar system. Okay? في changes بسيطة بالstructure. What they've done, they removed, let's say, that acyclic ring or cyclohexane ring, and also they substituted the amino glucose or sugar-like ring system with this aliphatic hydroxylamine. هل هاي النيتروجين still basic؟ يعني هل بتتوقع انه بصير لها ionization at physiological pH similar to this one؟ ليش لا؟ Is it still considered an aliphatic amine? Yes, it is still considered an aliphatic amine. ما في عندي pi systems حواليها اللي بتسحب الالكترونز via resonance واللي usually ممكن انها تقلل ال pKa بشكل كبير. فsomehow ال pKa for that nitrogen, which is considered an aliphatic amine, and it's a secondary amine. This one is primary. تقريبا ال pKa range لإلها similar to this one, which is around almost 10, I would say. Recall لما حكينا عن الدوكسورubicin حكينا إنه this group is very important for interaction أو for forming ionic interaction مع الphosphate بالbackbone of DNA. That is why when they changed the structure of doxorubicin, they kept this part in here. They kept the nitrogen because it's essential for activity. Yeah. هلا هيك additional information يعني برضو انتم مش مطالبين فيها. يعني one of the خلينا نحكي reasons behind the design of mitoxantron versus doxorubicin انهم they've noticed انه doxorubicin, by the way, which is used for treating leukemia and lymphoma, هو والother different drugs which are used for treating leukemia and lymphoma, الإشي المشترك ما بينهم إنهم they have this pharmacophoric bridge. 2 oxygens and a nitrogen, they form what looks like a triangle. The spaces ما بينهم مثلا ما بين 2 oxygens 3 angstrom, one of the oxygens and the nitrogen 6 والother one 8 angstrom. So when they designed طبعا this applies على doxorubicin. يعني if you look at doxorubicin, you have 2 oxygens and a nitrogen, and if you measure the distances between them, it somehow resembles the one that is seen بالpharmacophores for anti-leukemic والanti-lymphoma drugs. فعشان هيك الميتوزانترون when they designed it, they made sure إنه the oxygens and the nitrogen يعني مع كل التغييرات اللي عملوها بالstructure, they kept this or those 2 oxygens and the nitrogen and the distances between them to resemble what is seen بالpharmacophore. Okay? This one, high nitrogen, it's not يعني it's not necessary. هلا to answer this يعني to make sure that I answer this correctly, يفترض إنه إحنا نصنع an analog where I would substitute a nitrogen with a carbon حتى أعرف إنه هل هاي النيتروجين essential ولا لا. يعني بتوقع إنه ممكن هاي النيتروجين تعمل hydrogen bond interaction. فإذا بدلتها مثلا بكربون I will be losing high hydrogen interaction أو forming any kind of an interaction. يعني لو غيرتها ب CH مش راح يتأثر عندي الاكتيفيتي بشكل كبير. ممكن الفارماكوكينيتيك properties تتغير بس مش ال potency of the drug in vivo. Okay? طيب بما انك سألتي عن هاي النيتروجين, is this one ionizable?
No.
Yep. Yes, because the lone pairs on this nitrogen are present in a p orbital. This nitrogen is sp2 hybridized. فبالتالي راح يكون في عندي resonance withdrawal أو withdrawal through resonance. The electron density of this nitrogen, which is considered an aniline nitrogen, is very low. أو generally speaking أو مقارنة بالأليفاتيك amines يعني تقريبا بتكون ال pK لها around 5, 4, something like that. Definitely it will not be ionized at physiological pH. And even though they've substituted a sugar-like amino compound in doxorubicin with this aliphatic hydroxylamine, لكن still if you can, let's say, rotate the bonds, you may see, as in this figure, it can adopt the conformation of the sugar part with doxorubicin and it can form the same kind of interaction. Look at this crystal structure of mitoxantrone bound to DNA. Okay, لاحظوا إنه أنا عندي those 3 rings which are planar are intercalating ما بين the base pairs of DNA. Okay, and this nitrogen in here, which will be definitely ionized at physiological pH, is forming a hydrogen bond, an ionic interaction with one of the oxygens of the phosphate, which is part of the backbone. Okay, يعني تقريبا نفس الانتراكشنز اللي بيعملها الدوكسورubicin. الشيء الزياده او الشيء اللي let's say او superiority of this compound versus doxorubicin انه الكارديوتوكسيسيتي كثير اقل. طيب. ننتقل هلا ل another intercalating agent which is bleomycin. هلا would you expect انه this compound is a synthetic compound يعني شيء هيك بسهوله ممكن نحضره في اللاب؟ It's a very complex compound. Definitely it comes from nature. Okay. طيب لو بدكم توصفوه structurally, it is a complex, yes. Does it have any, let's say, structural features familiar into فيها? Some parts are hydrophilic, some parts are hydrophobic actually. Yes, the thiazole rings in here are planar. لكن generally لو بدكم توصفوا هالstructure يعني أو مثلا if you can identify certain structural parts فيه. Yeah, we have amide bonds يعني generally speaking we can consider part of it as being a peptide. Okay, what about those 2 in here? Yeah, they do resemble sugar compounds. So that is why bleomycins are considered glycoproteins. Because part of them are, let's say, made of peptide bonds between amino acids or resembles peptides, and here, this part of the drug resembles, let's say, sugar parts. طيب, هلا ليش احنا بنحكي bleomycins? Okay, because they were able to isolate many isoforms. يعني هاي the part which is highlighted in black is the same in all of the derivatives they were able to isolate from nature. The variations between them اللي هي R group اللي موجودة عندي that is connected to this carbonyl. Okay, مثلا ببleomycin A, it's this chain in here, this aliphatic chain. In let's say bleomycin, for instance, it is composed of this huge side chain. The variations ما بينهم or the side chain that is attached to here. تعرفوا شو variations ما بينهم أو which is which؟ أكيد لا، يعني مش مطلوب منكم تعرفوا إطلاقا. يعني إحنا اللي بيهمنا مثلا regarding the bleomycin إنه an intercalating agent نعرف which part is the intercalating part and how it does its mechanism of action. Okay. طيب. Which part do you think is the one that intercalates with DNA? Yeah. So this part in here, أو هاي thiazole ring عندي. Okay. أو those attached thiazole rings is the part that intercalates with the DNA. طيب. هلا can you see any ionizable nitrogens in this compound? اللي موجودين اونلاين كمان feel free to answer. Yes. Which one? كثير عندي NH. This one in here? Yeah. So that's an aliphatic amine. Okay. What else? Yeah. This one in here is also an aliphatic amine. Hi. What is this functionality? أمد. Exactly. هل بعتبر النيتروجين أنا في الأميدز basic؟ لا. Okay. طيب. هلا what is distinguishable or what is known about the mechanism of action of bleomycin is that this primary amine along with this secondary amine, okay, also the nitrogen of this ring اللي بنسميها ايش احنا؟ pyrimidine, exactly. This ring, imidazole. Yes, one of the nitrogens of the imidazole along with this amide nitrogen. يعني صح هو مرسوم بطريقة وكأنه هاي الاتومز بعيدة عن بعض، لكن لأنه أنا في عندي single bonds, this compound can rotate بحيث إنهم all of those nitrogens that I have circled, they can chelate with iron. And this chelation is what leads eventually to the breakage of DNA. يعني مش بس إنه بيرتبط بال DNA or intercalates with the DNA. This part in here of this compound, or in particular this part in here, I will show you, let's say, more elaborative figures. They can chelate with iron, and because of that, they can eventually lead to the breakage of DNA. We will talk about that shortly. All right. طيب. And here's a figure where I will show you a crystal structure. As I have mentioned, the imidazole or the nitrogen of the imidazole along with the primary amine, the secondary amine, one of the pyrimidine nitrogens, والأمid nitrogen اللي موجودة, all of them, they can chelate with ferrous iron. هلا, when we say chelates, do you know what we mean by that? Or what is the type of the bond that is formed مثلا ما بين هاي النيتروجينز وما بين الايرون؟ لا. coordination bond. والcoordination bond احنا بنعتبرها let's say a type of a covalent bond. هلا الcovalent bond لما بدها تصير بحيث انه يعني two atoms which are involved in the covalent bond, they equally share their electrons. يعني مثلا لو بدي يتكون انا عندي a covalent bond ما بين a carbon مثلا وhydrogen, what happens for this covalent bond to form إن الكربون رح تعطي إلكترون والهيدروجين رح تعطي إلكترون. Okay? In coordination bonds, the two electrons are donated by one atom, while other atom has an empty orbital that accepts those two electrons. تقريبا the strength of the coordination bond توازي almost the covalent bond. هلا why nitrogens in particular؟ يعني مثلا ما بين الكوردينيشن باند ما بين هاي النيتروجين والايرون، مين اللي عم بيعطي الالكترونز؟ ومين اللي عم بياخذ الالكترونز؟ مين فيه empty orbitals that can accommodate those electrons؟ الفرس. اوكي، الفرس ايرون in this manner. اوكي؟ طيب why نيتروجين؟ ليش النيتروجين مثلا الكوردينيشن لها احسن من الاكسجين او any other atoms بالسكند رو؟ Yes, exactly. هلا versus an oxygen, okay, electronegativity عندي أقل لأنه if you recall nitrogen, oxygen, fluorine, if you let's say move from left to right بالperiodic table, electronegativity بتزيد ليش؟ لأنه بالنيوكليوس أنا في عندي بروتونز أكثر، فبالتالي قابلية هاي النيوكليوس إنها تجذب الإلكترونز أكثر. فthat is why nitrogen is less electronegative than الأكسجين، بمعنى إنه هي عندها قابلية أحسن إنها تعطي هاي الإلكترونز. alright. وطبعا كل ما زادت الإلكترون density على النيتروجين كل ما كان الكوردينيشن أحسن. يعني مثلا ما بين this primary nitrogen والنيتروجين of the amide، مين أفضل إنها يعمل coordination؟ Yes, البرايمري امين، لانه بيكون عندي اللون pair is localized، الالكترون density اعلى مقارنه مثلا بالاميد نيتروجين اللي بتكون عندي الالكترونز are actually withdrawn via resonance to the oxygen. Alright? هلا اللي بصير انه when those nitrogens chelate with iron, iron then can interact with molecular oxygen, and because of that free radicals will be generated, وهاي free radicals will lead eventually to the breakage of the DNA strand. Okay, this is an extra figure رح افرجيكم اياه يعني شويه فيه هيك extra information اطلاقا انتم مش مطالبين بالمعلومات اللي هون. بس it's just to show you that those nitrogens that we have talked about, when they chelate with iron, they form what looks like what. يعني هاي الستركتشر عمركم شفتوا شيء مشابه له؟ I know, I meant before يعني in previous, let's say exactly الهيم moiety في الهيموغلوبين، الهيم moiety اللي موجودة بال metabolizing enzyme cytochrome P450 family, okay, where you have nitrogens that are chelating with iron, or even in some cases, let's say other kinds of transition metals. هلا when they do so, iron can now intercalate يعني interact with molecular oxygen اللي هو ال O2, وايفنتشولي بيتكون عندي a free radical as you can see. هلا هاي free radical once forms, what happens is that it will lead to the breakage of DNA strand. هلا the backbone of the DNA is composed of what? Yes, the backbone. Yes, alternating units of phosphate bound to deoxyribose, phosphate, deoxyribose, and so on. فاللي بصير إنه في deoxyribose part, الهيدروجين الموجود عندي على هاي الكربون then can interact with the oxygen, that free radical, okay, وبتنكسر عندي هاي البوند وبيتكون a free radical في الباكبون. طبعا we don't have to go through إنه what happens later, بس اللي بصير إنه eventually هاي البوندز بتنكسر. So what happens is that bleomycin, when it intercalates with DNA, بس أقلبك تسكري الباب لو سمحتي. When it intercalates with DNA, the rest of the structure can chelate with the iron. Such chelation will interact, or due to interaction مع molecular oxygen, eventually will break the DNA strand. Okay? طيب. I will show you a crystal structure نشوف فيه ال binding of bleomycin with DNA. And then we'll proceed with the chemistry of bleomycin. Okay, so what I'm showing you is bleomycin bound to a segment of DNA, okay, لكن it's coordinating with cobalt. يعني نفس الفكرة، سواء cobalt أو iron, it's the same. Okay. طيب عشان ما انتوا وبالآخر إنكم أنا أكون متأكدة إنكم you do know what I am referring to. هاي الكريستال structure مثلا لو إجاكم في امتحان, can you determine what it is؟ يعني ممكن تحكوا لي كل colored part إيش هو؟ طيب بما إنه هيك it has a helical structure. DNA. So that orange and let's say green part, those are the two strands of the DNA helix, of a DNA helix. طبعا a segment of DNA. All right? إيش هو؟ إيش الأطول إيه؟ This is a helix. It's not a beta sheet. By the way, يعني البيتا والألفا, this is for proteins, secondary structures of proteins. The DNA has only one secondary structure, which is a helical structure. Yeah, so that's the backbone of the DNA. طبعا مش كل الستركتشرز مبينة, يعني مش كل شيء, مش يعني الفوسفات, يعني it's here as if it's animated cartoon-like animation. يعني only if I click على one, يعني على أي segment بيبين لي الفوسفات والديوكسيرايبوز. بس for clarity okay خليني هيك let's go back to the for clarity it's not shown يعني what is shown only اللي هي ال base pairs والbackbone as if it's a strand okay طيب what about this part in here yeah that's the bleomycin okay لاحظوا if I would let's say zoom in what do you think this is أو هاي ال part of the structure فين هيك بس أحركها كمان شوي yeah those are the two thiazoles ولاحظوا إنها intercalating ما بين yeah here is the rest of the structure I am zooming in على highly transition metal ion which is in this case cobalt والفكرة سواء cobalt أو iron it's the same if I click on it راح يعطيني كل الانتراكشنز اللي عاملها هاي الكوبالت so let me click on it ولاحظوا البونز اللي عاملها as you can see لو بدنا نتبع على الستركتشر اللي موجود عندكم it is forming ثواني بس عشان أحركها وأحطها على ال right angle. Yeah, 6 coordination bonds بس بدي أشوف let's say الأمد والبرايمري أمين. Yeah, so that's the أمد if you recall اللي موجود عندي على ال end of the this glycoprotein. This is the primary amine forming one coordination bond. That's the secondary amine in here. That's one of the nitrogens of the pyrimidine ring. This is the nitrogen of what? Coordinating my cobalt. What is this part? Imidazole, exactly. والأمid that is right next to the pyrimidine ring. So 6 coordination bonds. طيب هل أنتوا أكيد familiar with the color codes of these softwares إنه كل atoms usually universally بنستخدم لها the same color. الأكسجين مثلا red, النيتروجين blue, السلفر yellow. All right. Everything else مثلا الكربونز على سبيل الهيدروجينز usually in white والكربونز حسب في بعض مثلا السوفت ويرز بنشوفها gray, orange as you can see in here. So you can vary the carbon color. But usually الأكسجين أو red coloration refers to oxygen, the blue coloration refers to nitrogen, the yellow to sulfur. Okay? طيب, what about this part in here? What is this? 2 oxygens bound together. O2. Yes, مش حكينا إنه once this let's say chelate forms الإيرون مع النيتروجينز اللي موجودة في البليومايسين, then that transition metal will interact with molecular oxygen وهالmolecular oxygen eventually بيعطيني a free radical وهالfree radical هو اللي بيتفاعل مع backbone of the DNA breaking it. Okay? Yes. 100%. This is what we will explain later. Almost diminished. هلا we will show you an example. مش إنه إحنا بنغير metabolism بصير عندي على الدرug and as a consequence the bleomycin activity will be diminished. Which is right in this slide. هلا هاي الأمد if you would convert it to carboxylic acid, okay, this will lead to the inactivation of the compound. هلا لما أحكي hydrolysis of the amide, hydrolysis gives you what? If you would hydrolyze an amide acid, a carboxylic acid. So look at this slide. This amide in here, all right, if you hydrolyze it, it will be converted into a carboxylic acid. Will pKa of the carboxylic acid كم تقريبا? almost 4 to 6 depending على الانفايرمنت اللي حواليها. Okay, it could be lower, could be higher, but usually for aliphatic carboxylic acids ما بين 4 to 6. طيب at physiological pH 4 to 6, an acid that has a pK of 4 to 6 بيكون mostly ionized ولا mostly neutral? Ionized, as you can see in here. طيب recall هاي الأمد هل بتشارك بالcoordination with cobalt أو iron؟ لا. Alright. طيب do you have any explanation ليش هاي الأمد if it is hydrolyzed into a carboxylic acid بيصير في عندي let's say yeah, the activity almost will be lost. Resonance مع إيش؟ For sure, carbonyl. That is why it's, let's say, مثلا versus aliphatic alcohols أو let's say hydroxides of phenols. الcarboxylic acids تعتبر more acidic because of the resonance مع الcarbonyl. طيب مين جنبها بيعمل كليشن مع الايرون؟ نيتروجين. اوكي. هلا هاي النيتروجين صح بتكون عندي let's say ionizable group, alright, لكن that or these خلينا نحكي numbers of molecules that the nitrogen is not ionized is the one that will be chelating with the iron. اوكي. هلا إذا صار للنيتروجين protonation هل can it be able to chelate with the iron? Yes. يعني بمعنى آخر إذا صار لهاي النيتروجين ionization اللون pair اللي عليها will be now bound to hydrogen. They will not be available to chelate with the iron. Alright? طيب how come if you hydrolyze an amide to a carboxylic acid, the activity of bleomycin is diminished. يعني شوي هيك بجوز تفسيرها is somehow twisted. It's not direct. Yeah. طيب. هلا to give you a hint, هل ال pKa of this nitrogen changes if you change the neighboring group from amide to an ionizable carboxylic acid? هل بتتوقعوا انها بتتغير؟ Yes. بتتغير. برأيكم بتزيد ولا بتقل؟ بتزيد، بمعنى انه البيسيسيتي بتزيد؟ لا، النيتروجين is basic. Yeah. ليش بتزيد عندي البيسيسيتي؟ Why do you think that? So let's agree إنه ال pKa of this nitrogen increases when you hydrolyze الأمide into a carboxylic acid. Why? For sure. Can you explain what we mean by this neighboring effect? Or how is this neighboring effect affecting the pKa of this primary amine? Donating a group. Yeah. That, let's say, carboxylate at physiological pH mostly will be ionized. Electron density عليها راح تزيد. بالتالي راح تزيد من electron density on that nitrogen. وبتزيد من ال pKa وبتزيد من ال percent of ionization. Inductively ولا via resonance ولا via both؟ ليش ما بصير في عندي resonance ما بين الكربوكسيليت وما بين النيتروجين؟ Yeah, because we have a carbon that is sp3 hybridized, which means إنه it will break any resonance يصير ما بين الكربوكسيليت وما بين النيتروجين. فاللي بصير إنه that carboxylate, okay, when ionized at physiological pH راح تزيد الإلكترون density على هاي النيتروجين inductively. لأنه أصلاً هي صار عليها النيجاتيف charge, it will increase the electron density inductively على النيتروجين. And by increasing the electron density, ال pKa بتزيد وال percent of ionization بتزيد. Alright? يعني بمعنى آخر مثلاً لو افترضنا جدلاً إنه أنا تقريباً عندي بجوز 95 أو خلينا نحكي 90% of that primary amine at physiological pH is ionized. The other 10% هو اللي بيعمل chelation مع الايرون هو اللي eventually راح يعمل لي cytotoxicity associated with bleomycin. لكن if I would increase ال pKa, ال percent of ionization راح يزيد. يعني بدل مثلا ما 90% at physiological pH يكون لها ionization ممكن ترتفع نسبة ل 99%, which means إنه very minimal of those primary amine functionalities في البليومايسين راح تكون available إنها تعمل chelation مع الأيرون. And because of that, if it's not chelating with the iron, ما راح يصير في عندي activation of the molecular oxygen حتى يعطيني a free radical that will break the DNA strand. تمام؟ Okay. هلا add to that what you have just let's say mentioned إنه any change بهاي النيتروجينز in terms of أغيرها ل something which is not ionizable أو أزيد from its ionization, وبالذات أنا بحكي عن هاي البرايمري والسكندري بحيث إنها no longer available to chelate with the iron, for sure الأكتيفيتي راح تتأثر بشكل كبير. ف that is why يعني for such a compound we wouldn't change anything in its structure. بالذات هاي النيتروجينز that chelate with the iron, otherwise we will lose the activity. تمام؟ You mean the increase increase the pKa? Yes. ما في resonance ما بين الكربوكسيلات والنيتروجين. It's inductively. It's an inductive effect. طيب. هلا ننتقل ل other anti-cancers which also let's say interact, which some are considered enzyme poisons, لكن they act via أو they do not intercalate with DNA. Okay. راح نحكي عن two of those أو two classes واللي هم الإيتوبوزايد, تينوبوزايد والكامتوثيسين. Okay. Yes. أنا حكيت مع الأكسجين. In here, those are the nitrogens of the imidazole, pyrimidine, the primary was secondary amines. That's the primary amine. That's the NH2 in here. Okay, and this is the amide that is right next to the pyrimidine. And 6 coordination bond بتصير مع الأكسجين. هاي the blue, let's say, circle is the oxygen. Yes. طيب. هلا التينوبوزايد والإيتوبوزايد, which are non-intercalating, let's say DNA, topoisomerase poisons, are called, or they are considered part of natural compounds that are podophytotoxins. Well, podophytotoxin has this structure. What they've done, this compound, which in experimental أو in vivo studies have shown some anti-cancer activity, لكن ما كانتش, let's say, strong enough to be pushed to preclinical and clinical studies. What was done in the podophytotoxin, the compound you see in here, they made structural changes عليه, giving rise to etoposide or tinoposide, all right? And those two صار في عندي great enhancement بالanti-cancer activity, all right? We call those compounds semi-synthetic because the origin for their structure أو حتى the origin for their synthesis comes from nature, لكن we did modifications على their structure. What is the variation between etoposide and tinoposide? What is the difference in structure between them? Sugar units أنا شايفتهم the same. أو sugar-like units. Yeah, the substituent على let's say this ring in here. Here you have a methyl, and tinoposide you have, what do we call this ring? Thiophene. All right. هلا replacing الميثيل with the thiophene highly increased, let's say, cellular uptake, وبالتالي زاد عندي من cytotoxicity associated with it. هلا الactivity for التينوبوزايد والإيتوبوزايد is very similar to doxorubicin. They do bind, or they are considered poisons for topoisomerase 2, بمعنى إنه بيرتبطوا بالtopoisomerase 2 and DNA, the substrate of topoisomerase 2. وبيشتغلوا على نفس الستep. يعني if you recall لما حكينا احنا عن topoisomerase action انه it binds with DNA, breaks the DNA strand from 2 points or 2 strands of a DNA helix, let's say removes their relative positions from each other and then religate the broken DNA helix. هلا التينوبوزايد والإيتوبوزايد زيهم زي الدوكسوروبسين بيرتبطوا بالcomplex of topoisomerase 2 and DNA after it's already broken by this enzyme. They stabilize such a complex وبيمنعوا الانزيم انه يعمل religation. All right. Here's an image. يعني أنا رح فرجيكم الكريستال structure باختصر هاي images. This one, the one right next, let's say after, and this image in here, which shows the interactions ما بينهم. I know it's very complex, بس معلش we'll go يعني through the structure and analyze it one by one. هلا عشان بس هيك يعني أحسن الصورة شوي بدي أشيل الووتر. يعني by the way يعني هاي ال icons that you see in here, you can for instance choose مثلا I don't want to see the water molecules. Just click on it بتروح عندي كل هاي ال red dots which represent the water. طيب. لو حكيت لكم what is the classification of those two biomolecules اللي موجودين عندكم؟ هل is this DNA or is this a protein or both?
Both.
Yeah, تفضلي اللي in line. بالضبط. Yeah, that one you see in here is DNA and what's around it is the protein. كيف ميزنا البروتين؟ Those alpha helices or beta sheets for sure it's let's say a protein. And the one you see in the center represents the DNA. I just want to show you ligand واللي هي for this crystal structure which is let me let's say click عليها and rotate. So that's the ligand in here. هلا لو سألتكم هل ممكن تميزوا انها ايتوبوزايد ولا تينوبوزايد؟ ممكن؟ وين اعمل زوم ان على ايش برأيكم؟ بس خليني احاول هيك احركها عشان تصير اوضح. What do you think? So this is etoposide. Yeah. So that's the sugar part along with the هلا في السلايد اللي قبل حكينا انه الفاريشنز ما بين التينوبوزايد والإيتوبوزايد انه انا instead of a methyl we have a thiophene that is attached to those let's say cyclo or those two 6-membered rings اللي هم the ones you see in here بالchair conformation. كيف انا بميز by the way cyclohexane and cyclohexane like structures انه بيكونوا they have a chair conformation. So those two rings in here. معلش bear with me انه شوي احاول احكي مع مركز الحاسوب يعني hopefully انهم يزبطوا لنا اياها. يعني try it at home. You will see انه it's really very nice يعني to move those structures and see the binding from all different angles. هاي الجروب اللي موجود عندي هون is a methyl which tells you it's etoposide not etoposide not tinoposide. التينوبوزايد instead of a methyl بيكون في عندي a thiophene. اوكي هلا يعني سؤال انا بجوز نسيت اسالكم اياه before. Let me go back to the slides. ليش احنا ما بنعتبرهم intercalating؟ يعني ليش ما بنعتبر الإيتوبوزايد والتينوبوزايد intercalating؟ Yeah. I don't have a planar ring system in here. So this one is a planar, like in this one cyclohexane, it's not planar. So it's not a planar ring system. So it will not efficiently intercalate the DNA. That is why we consider it a non-intercalating. طيب يعني أنا بس اللي كنت حابة أفرجيكم إياه بهالكريستال structure. You don't have to worry about ال huge أو so many interactions اللي بيعملها الدرug، مش بس مع الدي ان اي، برضه كمان مع التوبوisomerase 2. يعني the reason why this drug is considered a poison to topoisomerase 2 مثلا مش other proteins، لأنه it fits well in its binding cavity. It forms strong interactions معه. That is why it's a very strong suicide inhibitor for the topoisomerase 2 زي الدوكسوروبيسين على سبيل المثال. Okay. recall حكينا إنه هالإنزيم بيكسر الدي ان اي strand أو الهيلكس from 2 points، أو بيكسر 2 strands بالدي ان اي هيلكس. بس هيك شوي بدي أحاول أحرك لك structure بس عشان أفرجيكم إنه الباك بون is broken. The backbone of the 2 strands is broken. Let me see. I know البوليمر بس ما هو بيعتبر both the DNA وال both of them. Let me see if I can. Oh, I'm sure there's a way. Okay, hopefully هيك صارت أوضح. هو أحسن إشي أنزل أنا سوفت وير ونصير ننزل الستراكشرز ونستخدم السوفت وير أحسن من هالويب سايت. هلا one of the backbone strands is in orange. فلاحظوا أنا عندي هون this part and this part they are broken. Same thing for the one in violet. If you rotate it, you can see, you know, at here there's a breakage point between this one and this part in here of the helix of the strand. So there are 2 broken points with DNA helix, and what in tinoposide or etoposide do, they bind to this complex and they stabilize such a complex بحيث انهم يمنعوا الانزيم انه يعمل religation. وايفنتشولي راح يصير في عندي many breaks بالDNA that eventually lead to the programmed cell death or apoptosis of those cancerous cells. طيب I will try to fix this. يعني ضروري نصير نطلع على هاي الكريستال structures، فبدنا هيك طريقة أحسن عشان so that we won't waste time. هلا بهاي السلايد the interactions that the drug forms, whether with the nucleic bases of the DNA or even the amino acids of the topoisomerase 2. مش ضروري انكم تعرفوا exactly ايش هي الانتراكشنز. يعني what really matters for you is to understand انه this drug forms interactions with both the DNA و topoisomerase 2. طيب هلا another important feature for الاتوبوزايد وبرضه كمان التينوبوزايد, it's not only etoposide, is that you have a hydroxyl at the para position in here. Para, we mean para to the rest of the structure or to this substituent على هاي البنزين ring. هلا what was found إنه experimentally, if you would remove that hydroxyl or if you methylate it, we will lose some of the activity أو تقريبا جزء كبير من الactivity. هلا the reason for that أو the explanation for that إنهم they found out إن those two methoxys اللي موجودين عندي على الميتا position, they get metabolized. Any of them, not necessarily both of them, any of them if metabolized or when metabolized, والmetabolism اللي ممكن يصير على methoxy group according to this scheme is what? Yeah, بصير في عندي OD alkylation, okay? Giving rise to two hydroxyls right next to each other. Do you know what we call this structure لما يكون في عندي two hydroxyls على بنزين? Catechol, okay? That catechol can be easily, let's say, oxidized into a quinone. This quinone, زي ما شفنا بحالة الدوكسوروبيسين, may lead eventually to the formation, it can chelate with transition metals such as iron. بالتالي بصير في عندي, let's say, eventually formation of free radicals, بزيد عندي reactive oxygen species, which leads to increasing the oxidative stress بالcancerous cells, and that's another mechanism via which الالتوبوزايد والتينوبوزايد act. مش بس إنهم poisons to topoisomerase 2, but also they can generate reactive oxygen species. All right. So this hydroxyl at the para position, along with one of the methoxys على الميتا positions, are essential for activity. Okay, but that high OH, if you would change it, remove it, mask it with a methyl, for instance, بقلل بشكل كبير the generation of the quinone, which is essential for the activity for الاتوبوزايد والتينوبوزايد. طيب. لا بالعكس, this is الميتابوليزم اللي بصير is what leads, let's say, to a metabolite which leads to the killing of the cancerous cells. عشان هيك إذا أنا بشيلها هاي ال OH أو بحولها into a methoxy ما راح يتكون عندي الكينون, والكينون ضروري عشان الactivity of الاتوبوزايد والتينوبوزايد. That's another mechanism via which this drug acts على cancerous cells. طيب, look at this structure that I've just shown relative to etoposide. شو الchanges اللي فيه؟ الفوسفات جروب وين ضفناها؟ وين ضفناها؟ على ال OH, which is على ال para hydroxy group. طيب, how do you think this will affect the polarity of the compound, the water solubility? Yes. هلا the reason for such a change إنه أنا عندي الاتوبوزايد has poor water solubility. وthis is يعني for sure احنا يعني أكيد تعلمتوه في medicinal 1. Lipophilicity is essential for the passing of drugs through cell membranes or eventually to their targets. لكن if the compound has no water solubility whatsoever, it cannot approach the water layer or it cannot approach even cell membranes. فما راح يصير له cellular uptake. For some degree of water solubility is necessary for drugs to pass through membranes. هلا الاتوبوزايد has poor water solubility, so what they've done is that they let's say added a phosphate group على هاي الهيدروكسيل group. Okay, طب شو احنا حكينا هاي الهيدروكسيل ضروريه عشان يتكون عندي الكينون. طيب yes, yeah, exactly. So that phosphate group which highly increases the water solubility لأنها an ionizable group can be easily removed by phosphorylases. ما بنسميها dephosphorylation وإنما hydrolysis. يعني simply بصير عندي hydrolysis of that phosphate group. It can be easily removed. Okay, once in the system. So this compound, we consider it a prodrug. Okay, it's a prodrug. It needs to be activated in vivo or bioactivated to give rise to the active form of the drug, where I need to have this hydroxyl free. All right, we still have enough time نحكي عن الcamptothecin, the last one in the non-intercalating topoisomerase compounds. بعدين بنحكي إن شاء الله أول محاضرة جاية بنبلش بالalkylating agents. طيب, look at camptothecin. This drug in here. This compound also similar to الpodophylotoxins, الetoposide والtenoposide, is also considered a suicide inhibitor, a poison, لكن مش the topoisomerase 2 وإنما topoisomerase 1. Do you remember the variations ما بينهم اللي حكيناها؟ شو الاختلاف ما بين 1 و 2؟ بالضبط. Yeah. So topoisomerase 2, when it binds to DNA, it induces two breaks with two strands في DNA helix. Topoisomerase 1, okay, leads to breakage in only one strand, rotates, let's say, the broken one, but then بعمل religation. Okay, that's the only difference between them in terms of the function. هلا الcamptothecin زيه زي الدوكسوروبيسين, زيه زي الetoposide والtenoposide. It's a suicide inhibitor, binds to the complex of topoisomerase 1, which is in this image shown in yellow, okay, and the DNA. It stabilizes the complex بعد ما already الانزيم كسر ال DNA, عمل one breakage be one of the strands of the DNA helix. Stabilizes such a complex لأنه بيعمل interactions with the DNA and the enzyme, it prevents the religation. فبضل عند ال DNA مكسور. Okay, which eventually will provoke a programmed cell death أو apoptosis. تمام؟ Okay. طيب. يعني I don't have to look at the crystal structure. يعني I'm sure this image is clear أو يعني hopefully صار عندكم انتو enough. يعني from now on يعني some of the أو many of the crystal structures مطلوب منكم إنكم تطلعوا عليها. بس مش رح يعني كلها إحنا نتناولها في المحاضرة إلا إذا في شيء معين أنا بدي أشرح عليه. لأنه hopefully now you do have the skill to be able to distinguish the biomolecules, the interactions اللي ممكن تعملها targets مع their drugs. إذا نحكي regarding الcamptothecin, إنه one of the, let's say, chemical modifications اللي بيصير على هالدرug after it's being absorbed, okay, is this process, which is what? Look at the product and compare it with camptothecin. Sorry, what happened here? Ionization? Yeah. The breakage of what? The ester. هلا لما تكون الester cyclic ester شو بنسميها؟ Lactone. Okay. So what happens at physiological pH is that lactone can be broken into the corresponding, okay, carboxylic acid والكحول. طبعا والcarboxylic acid بصير لها ionization أو deprotonation at physiological pH. لأنه ال pKa لها تقريبا 4, الميديا 7.4 بتكون slightly basic لها عشان هيك بصير لها deprotonation أو ionization. Okay. Now this is a bad thing regarding yes. هلا what we mean by hydrolysis إنه بيكون عندك ال water molecule interacts with this carbonyl, okay, تنكسر. For that all came from water. All right, that extra oxygen is from water. Now the issue for camptothecin or why this process leads to inactivation of camptothecin أو بتقلل الactivity in vivo بشكل كبير. السبب لأنه that carboxylic acid when formed, okay, it leads to greater binding of camptothecin with let's say plasma proteins. Okay, يعني you do recall I think one of the functionality which increases the binding of drugs to serum or blood proteins such as الالبومين على سبيل المثال انه بيكون في عندي acidic functionality. فذات acidic functionality now revealed in camptothecin in vivo will increase the binding of this drug to albumin. Once bound to albumin, yeah, as if it's not present in there. It will not, let's say, I will not be in therapeutic levels needed for binding to, let's say, their target. All right. هلا, what do you think الchemical modifications اللي ممكن نعملها برأيكم؟ أو يعني what approaches you may think about حتى إنه أنا أقلل من binding to albumin مثلاً أو serum protein such as albumin بدون ما أغير من اللاكتون أو أي شيء حواليها. Yeah, that's one way. That's a good approach. Yes. Hello. Yes. تفضلي. So that's, let's say, a very rational approach. إنه أنا ممكن let's say أضيف substituents على الكمباوند يا إما to hide let's say اللاكتون أو بقلل من binding of the drug to albumin itself. يعني حتى لو بعمل أنا hiding ممكن إنه rate of hydrolysis مش كثير يتأثر إلا إذا أنا بدي أغير بالchemistry of the lactone و somehow أو electronics باللاكتون و somehow this is hard may lead to inactivation of the drug. So a very safe approach that they've amid هلا ممكن بس to tell you the truth I haven't seen in literature any researcher who did this انهم غيروا اللاكتون into a lactam. هلا ممكن اذا غيرناها طبعا for sure الهيدروليسيس بقل بشكل كثير اكثر لانه يعني you already know الاميدز كثير اصعب يصير الهيدروليسيس versus الاسترز. لكن in terms of how it will affect the binding of the drug to its target I'm not sure. يعني this analog should be synthesized or tested حتى إنه to confirm إنه إذا بغيروا الأميد هل بيأثر على binding of the drug or not. But I haven't seen in literature this. Probably جربوه بس such information is not published. لأنه what eventually was done, okay, they've changed, let's say, or they've added substituents على هاي rings which affected binding to albumin. قللت من binding of the albumin. لكن ما أثرت على الهيدروليسيس of that lactone أو that lactone. Okay, examples على هاي substituents, let's say a tertiary amine hydroxyl group, or as in the case of irinotecan, let's say these, let's say 2 cyclic rings that were attached to this aromatic ring in here. طيب هلا بالايرينوتيكين هل في عندي أنا ionizable groups؟ يعني بالتوبوتيكين I've already pointed this nitrogen which is a tertiary aliphatic nitrogen is definitely ionizable. What about the irinotecan? Which one? I have 2 nitrogens. Yeah, this aliphatic in here. هاي الرينج شو بنسميها by the way? Do you know? Piperidine or piperidine. Yes. Now this nitrogen is basic. It's a tertiary aliphatic nitrogen that can be ionized at physiological pH. هلا these substituents that were added at this ring صح هم far away from the lactone لكن the point of making such changes is for the purpose of lowering the affinity to albumin مش إنه رح يأثر بشكل كبير أو مباشر على the hydrolysis of the lactone into the corresponding carboxylic acid. هلا بالirinotecan what they found out. Yes. تفضل. اوكي هي اخر معلومه انا راح احكيها. يعني الايرينوتيكين by the way they found out انه experimentally in vivo what happens is that this group undergoes hydrolysis. Do Do you know what is the name of this functionality? Carbamate, exactly. Carbamate, or in literature you may see it as being called as a urethane. هلا الكارباميت is a hydrolyzable group. صح أصعب من الأستر، أصعب من الأميدز. It's hydrolysis, لكن still it happens in vivo, بالذات with the presence of enzymes. So when that functionality is broken, it will give rise to the free, let's say, alcohol, and this compound is the one that binds to topoisomerase 1 and DNA. Okay. With this, we have finished chelating and interchelating agents. المحاضرة الجاي رح نبلش نحكي عن الالكيليتنج agents. يعطيكم ألف عافية. اللي موجودين أونلاين في حدا عنده أي سؤال؟